This is the solution set for vectors number 6. The first step as we make our way through vectors number 6 is to pull out the given information. We know that by reading our problem we have a force pulling on our cruise ship going to the west of 6,000 newtons. We also have a force pulling to the north of 8,000 newtons. The next step is to draw out our vectors as they would emerge from the origin. I've used a scale of 1 block equaling 500 newtons. This will allow me to make the vectors large enough so that it is easy to see and easy to manipulate. The first vector that I draw is the red vector, which is our force represented towards the west. Second vector being the blue vector, which is our force to the north. I then redraw the first vector, or my force to the west, of 6,000 newtons. From the tip of that vector, I then draw the force towards the north of 8,000 newtons. I then am able to draw the resultant vector using the orange vector, which will represent the resultant force that is acting on the cruise ship. Now, using the Pythagorean theorem, I can solve to find what the resultant force is that is acting on our cruise ship. So if we use the Pythagorean theorem of a squared plus b squared is equal to c squared, and we rearrange that so that c is equal to the square root of a squared plus b squared, and then we plug in for a 6,000 newtons and for b 8,000 newtons, we'll be able to easily find the resultant force acting on the cruise ship. By plugging it into our calculator, we can easily find that our resultant force acting on the cruise ship is 10,000 newtons. The second question asks us about a jet that is flying west at a velocity of 90 meters per second. So to pull out our given information, we have a velocity towards the west of 90 meters per second. And then we know that we are flying into a headwind of 20 meters per second. Well, that means that that velocity is pointing towards the east. We are then experiencing a crosswind of 30 meters per second, which is traveling towards the north. So I begin by pulling out that information and then drawing each one of my vectors as they would emerge from the origin so that I can see all of the velocities at work on one object or on one individual point. So we have our velocity towards the west, our velocity towards the east, and then our velocity towards the north. Again, we're using a scale of 10 meters per second is equal to 1 block. I then use the tip-to-tail method to add my vectors from the origin out to the end of all three vectors. I then draw the resultant vector from the origin to the tip of our final vector. Part E asks me to determine the resultant velocity of the jet. So to do that, we need to understand and know how long in the x direction our resultant vector is, or what component, and that is 70 meters per second, and then how high it is in the y direction, which we know to be 30 meters per second. Now we can use those two values and set up using the Pythagorean theorem, which again, as you know, is a squared plus b squared equals c squared. Again, we'll solve for c by using the square root of a squared plus b squared. Once we've plugged in all of our information, squared them, added them together, and taken the square root, we end up with a resulting velocity of 76.16 meters per second. Again, if you have questions about these or any other problems during class, please be sure to post them on our class website.